Hey everyone, and welcome to this DBT, or otherwise known as the Data Build Tool tutorial. In this tutorial, you're going to learn how to write models, transform your data with SQL, as well as many other things including macros and jinjas, all in DBT. There are two tutorials before this that you may want to take a look at, which is the Docker and SQL tutorial that we have done. I recommend going back and taking a look at those tutorials as it'll set the stage for this tutorial here, but in any case, there are links down in the description that you can go to and use in case you get lost. But without further ado, enjoy the video. There are a couple prerequisites you need in order to run DBT successfully on your machine or even using Docker. So let's go ahead and take a look at what that looks like and actually get it installed. All right, so I'm here on the DBT docs, which we will also list down in the description just so you can get to it pretty easily. Now, there is some things you need to do locally. Not everything you can do here through Docker. So the first thing you need to do is, obviously I'm on a Mac, so most of the instructions here are going to be for Mac, but you do need to have this installed locally. And the way to do that is if you probably have pip, if you have Python installed. And so you're going to follow all these instructions. I think you could pretty much skip these ones right here. You're going to want to follow this one for sure. I think actually you could probably skip that one too. The main one here is installing the actual adapter. You're not just installing the adapter, but you're also installing DBT Core, which is the open source version of DBT. Now, I've already done this, but if you run dbt install dbt-postgres, we're installing the adapter of Postgres that utilizes DBT as well as DBT Core. So you're going to go ahead and run that locally. I've already done that, as you can see here. So if I say dbt-version, you can see that it's going to list pretty much. I have 1.62 installed. I'm not going to update for the sake of this tutorial, but there's 1.66 and I have the Postgres version installed as well. So make sure you go through this installation really quickly, and that way we can actually go through and create our models. So make sure you do that. That is just the only prerequisite for this section. Okay, so now that we have DBT installed, let me go ahead and show you how we can initialize a project here. So it's as simple as dbt init. So we're going to run dbt init inside of the root directory, Now it's going to ask us for the name of our project. We're going to say custom underscore Postgres. So it's going to say custom underscore Postgres, and you can see it's creating these folders here for us. Now we have the database we would like to use. It's asking us right here for Postgres, and obviously it's the only adapter that we installed. So we're going to hit number 1. It's created 2 folders actually. If we take a look on the left-hand side, it's created logs for us. So we now have logs for anything regarding DBT, as well as our project for DBT. So it has a couple folders here: analysis, macros, models, seeds, snapshots, and tests. Primarily what we're going to be focusing on is the models and macros for now. And then the rest of it is kind of like, you can learn as you go. But for the sake of this tutorial, we're going to be focusing on these folders here. So there are other couple things that we need to do in order to set up the project itself before we actually write our models. The one thing we actually have to do is going to be this. So I've just copy and pasted this one command, but you're going to do nano, and inside of the complete root of your local machine, when you install DBT using pip, it actually creates this .dbt directory. And inside that folder is a profiles.yaml file. So what we're going to do is go in there, and you can see that I've already set this up. But inside of the dev profile, it does say Postgres underscore transformations. I'm going to go ahead and change this because this is now different. So what I've done now is I'm going to change the name of this because it's no longer Postgres transformations. That's what I normally did. This is going to be custom underscore Postgres. You can see it's done that down here. So it is actually done that down here. Actually, you know what? I'm probably just going to do that instead. I'm going to Postgres. So now that we're inside of this folder, you can see that I've already done this prior, but if we were to go down here into the custom Postgres profile, which is created for me because of this new project, we can see here there's 2 different outputs. There's prod and dev. We're going to be primarily focusing on dev, and we do need to fill out the actual information here. So inside of host, I'm actually going to do host.docker.internal, which is needed in order for DBT to actually recognize the Docker containers that we were trying to access here, which is going to be our destination database. So make sure that this says host.docker.internal, and it'll read the actual network or IP address of your Docker container for the destination database. For the port here, this is going to be 5434, I'm pretty sure, for the destination. For the user, we're going to change this over to Postgres. For the password, we're going to change this over to secret. DB name will be destination_DB. And then I forget what I actually put for the schema here. Schema should be public. And then I forgot to fill out the threads here. So let's change this to 1. All right, cool. So, and the target here is going to be dev. So obviously make sure that says it. By default, it should just target the dev profile. But now that we have our information filled out here, it should have the correct information to connect to our destination database. Now, if I do, I believe if I do write out, maybe not write out, but if we say X, save modified, we're going to hit yes, tab to complete, and hit enter. Okay, so this should have saved it. Now, the other thing to do here is inside of the dbt_project.yaml file, the one thing to note is that obviously the profile we just wrote is the custom_Postgres. You don't have to change anything here except for this bottom section. Inside of the bottom section is going to be how we're forming our models. Now, inside of the models folder, you can see that there's an example folder and then a couple of models here. What we're actually going to do is there's a couple options inside the materials section, but because we're using Postgres tables, we actually want to change this to table. If you keep it as view, we're actually not going to see any of the tables that we created come through or anything like that, or DBT is not going to be able to recognize them. So we have to change it to a table. Now that we've done that, we can actually go in and write our models. So let's go ahead and do that. All right, so we are inside of the models folder here. And inside of this example folder are some custom examples that they have created for us. We don't really need to see this because we're going to be writing our own. So I'm actually going to go ahead and delete both of these. We're going to keep the schema.yaml for now. Well, we're going to reference that later, but let's create our models here. So you can think of models as just SQL files. We're just querying the data, but we're morphing the data around to the needs that we need. So we just do it once here, and then once the destination database has its data, everything that we've queried here, all the modifications and the new tables that we've created will end up inside of the destination database. And you'll see what I mean by all that once we have it all hooked up. The first thing we need to do is actually source the data itself, because it can't just simply reference tables inside of a destination database without having the actual reference itself. So what we're going to do is we're going to create our first one. So we're going to say film_actors, which is a table that we're actually writing over into the destination database. And this is simply just creating a reference for us to create the custom models. So this isn't necessarily a custom model here. So we're going to write some SQL here, select all from, and then we're going to do double curly brackets here. And inside of that, we're going to say the source of our data is going to come from destination_database. And the name it for this that we're going to reference it from is going to be film_actors. And that's pretty much it. So we're going to need to wrap both of these in single quotes. Very cool. Now, what we've done is we've sourced the destination database and we've taken the film actors table. And now we have a film actors reference. We're going to do that. Let me go ahead and copy and paste this. We're going to do that again for the actors table. So actors.sql. We're going to paste this in here and we're simply going to change this over to actors. And we're going to do the same for films.sql. Now change films. Now, so we have our references. Now we can actually create our custom models. But again, before we do that, we have to have some prerequisite work. So for the schemas, these are our custom models here, our DBT models. And we do have to specify what the schema of these are going to be so that if we do need to test anything, which you should be testing, you can run a model or you can run DBT against all of these SQL files. And if it doesn't match what we've specified inside the schema, we're going to get thrown back errors. So you should definitely always do this. What I'm going to do is I'm going to head over into our file here, and I'm going to look into the models and example folder, and we're going to have a couple things. So schema.yaml is what we want. We see that there's a films table here, and every bit of of schema here for that one, the actors, film ratings. So what we're going to actually just do here is copy and paste this whole thing. So I implore you to do that too. We're going to paste that in there. And now we have the schema for all the tables that we just added. Now, the other thing too that we need to do is we're going to go ahead and copy over the sources.yaml. So now we're specifying the raw data from the destination database. So I'm going to copy this as well. And you can see film actor and film actors, literally the exact tables that we just copied. So we're going to go in here and create a new file called sources.yaml and paste everything that we just saw. So now we actually have sources that we can point to regarding these three tables, essentially, that we're querying from. So you can see now, like if we think about this from the top down, data is theoretically already written inside of the destination database. DBT is going to run after we've moved data over, so the data is already there. So what we're doing here is we're querying actors, and the films table. And from there, what we're doing is taking in the data, so that way we can modify it and create a custom model with that data. So all we're doing here is referencing data that we already have. Now let's go in and create the custom models to formulate and modify the data we have into a table that we want. Okay, so the first model we're going to create inside of the example folder, I'm going to name film_ratings.sql. So what we're going to be doing is appending the films as well as the actors together to create one table, but it's going to be primarily focused on the film ratings. So let's get to it. So what we're going to do inside of this file is we're actually going to create two different tables and then use a join to create one, if that makes sense. So the first one we're going to call is with films_with ratings as, and then this is where we're going to run our SQL to create this table. So we're going to say select film_ID title, release_date. Make sure you're adding commas, price, rating. These are all from the table that we already have. This is going to be user_rating. And then this is where we add something very specific. So this is going to be a case. So what the case is, kind of like you can think of an if statement per se. So we're going to say when user_rating is greater than or equals to, let's say 4.5, then we want the rating to say excellent. We're going to add another one where user rating is going to be greater than or equals to 4.0. So kind of like in the in between there. Then we're going to say that we want the rating to read good. And then the last one we're going to do is going to be user rating is is going to be greater than or equals to 3.0. Then we're going to say that this is going to be average. Else we're going to label it as poor. And we're going to end as rating_category. So that ends this case statement here. And this is where the reference comes in. So we're going to say from, and we're going to open the double curly brackets again. And if we say ref parentheses films, we're going to be pulling from this here because we labeled it as films. So now we can actually reference it here within this little query here. One thing I forgot to mention for this specifically is you saw that we say with and as. So with films with ratings, this is actually what's referred to as a CTE or common table expression. So you can see this as a wrapper of this query, kind of like a subquery per se, but it makes it easy to write queries that are maintainable, and they're also scoped just to this CTE, so it will not like go outside of this. So this allows us to write subqueries and then ultimately reference them later inside of this file. So it is actually a really, really nice part of DBT that lets us write CTEs to kind of formulate these custom models. So that's just something I forgot to mention when we were first writing this, but remember this as a CTE or common table expression. All right, so let's write the second one. I added a comma after the CTE so that way we can string on another one. This one is going to be films with actors as, and then that's going to open our CTE here, our second one. So we're going to say select, and we're going to do the alias here. f.film_id, f.title, and then we're going to do a string aggregator or string aggregation with a.actor underscore name. And we're going to append it with a comma there. And we're going to do as actors. So we're aggregating actor names for each film here. And then we're also going to hit the reference. So from double curly brackets, reference films. And then obviously we're going to enable the alias here with F. I don't know why it auto completes that, but there we go. So then we're also going to left join film underscore actors table. And we're going to give that FA for film actors on f.film underscore ID if it equals the film actors dot film underscore ID. Perfect. We're going to do another left join here, referencing this left join. We need this. So let's go ahead and do that. So forgot the curly brackets, or I'm sorry, the parentheses and the single quotes there. Let's add the actors for this reference. Obviously, this one is going to be A on fa.actor underscore ID if it equals the a.actor underscore ID. And then we're going to group by the f.film underscore ID and the f.title. Okay, so that's going to be the second CTE. So we have two now, technically two queries, films with ratings and the films with actors. So we've taken the film ID and the title, and we've joined the two tables that we had here. We had the film actors and the actors table. So these are obviously, we worked with these before, but the film actors and the actors is the bridge to the films table. So now we can actually join them to create one. So now we're going to have the main query here. We're going to select fwf.asterisk here, and we're going to say FWA film with actors actors from the films underscore with. Now you can see underscore ratings. You can see how we're referencing the actual CTE now, and that we're going to label this as FWF for the alias. And then we're going to say left join films with actors, which we're going to label FWA on FWF dot film underscore ID if it equals the film with actors dot film underscore ID. So now you can see that now we're creating essentially what could be two tables using the references we've created. And now we're actually joining them together using this custom model. Now, if we were to want to run this, we now need to set up the Docker container for DBT. So let's go ahead and do that and then run this custom model just to see what it would look like. Okay, so we are back inside of our Docker Compose file. Let's go ahead and add the DBT service. So underneath the ELT script, I'm going to say DBT, which is going to be the name of our service. The image I want to use is going to be ghcr.io/dbt labs/dbt postgres. And then the version is 1.47. As of right now, at the time of this recording, is most likely out of date, but it's just what I use. So I'm going to go ahead and run with it. The command I'm going to run here. Now I'm going to open these square brackets. And the first one I'm going to do is run. So this is technically dbt run. Dbt run is the command you would use in order to run your models on top of the destination. So I'm going to string a couple here. So we're going to say run. We're going to point to the profiles directory. So if I do double hyphen profiles hyphen dir, not period, I need a comma. We're going to say that is going to be in the root here. And then if we're going to point to the project directory, then we're going to point to /dbt, which is essentially going to be the name of our project directory here. The one thing I also want to do, well, we can leave this out for now, actually. So after that, we're going to do networks, and this will be ALT_network, so we can keep it on the same network here. And now we're going to point some volumes here. So with the volumes, we have the actual project itself. So you notice I said /dbt. So here we're actually going to create another mapping to point to /dbt, because if we remember correctly, on Docker containers, every directory here is pretty much going to be pointing to the directory inside of the actual Docker container and not your local machine. So you have to map the Docker container to look at where the actual project is going to be on your local machine. So we're going to create that mapping, and this is going to be ./custom_postgres. Postgres. And then from there, we're going to do the colon to create the mapping to the container path. And then the container path is simply just going to be /dbt, which we've pointed right here. Now we need to create another volume here. Let me add a space here because that requires a space. We're going to point to the dbt profile that we did. So we're going to need the squiggly tilde. We need squiggly /dbt, and we're going to point this over into the root, which is where we've pointed, if I could spell normally. This is where the profiles directory was, which is going to be in /root. So now we're mapping our local dbt folder with the profiles.yaml file to the /root of the Docker container. Hopefully that makes a bunch of sense, because in my mind it kind of does. So we're also going to say depends on the ELT_script. So we want dbt only to run, because remember, when this container starts, we're running this command. And if we run dbt run on top of the destination database without it having any data, this will not work, because it has nothing to reference and it has nothing to write data on. So we need this to make sure that it depends on the ELT script, and the ELT script depends on the two databases. So this is working down the line. We've essentially created a work line here. And then for the environments, not entry points, environments, we need 2 here. So we need dbt_profile. And this one is going to be, it's actually not an equals. I don't know why it does that, but it's going to be default. And then we have another one. This one doesn't need a hyphen actually, because we made that mistake last time. And then we need dbt_target. And this one is going to be dev. Okay. So this is going to be everything we need for the dbt container. Now, all we need to do, go ahead and clear this. I don't think Docker compose down. Go and Docker compose down everything. I think the volumes are still up, but that's totally fine. So now we're going to do Docker compose up. Did I type that correctly? hcr.io/dbt-lab/dbt-postgres 7. Oh, 1.7. Okay, that's another one, another typo. There we go. So we're going to go ahead and let that run here. So ELT script exited with code 0, so that's a good sign. Now the dbt one should pop up. Invalid, not a project, missing dbt_project.yaml file. Okay, so invalid project directory. Project directory here, custom_postgres. Maybe we do not need this. Let's go ahead and clear this. Let's do Docker goes down /v, and then so maybe custom. Oh, I'm dumb. It should have been an underscore. You can see all the typos, and everything really does make a difference here. So let's run that again, and that should map to the correct project now, hopefully. There we go. So it's ran successfully, I think. Unable to do partial parsing. Encountered an error sources.yaml, runtime error sources.yaml. List of actors, film actors, raw error while parsing a block mapping Unicode. Okay, so there was an error in our sources file here somewhere. That might have been it. 13 and 14. Film_actors. Okay, let's do this one more time. I think my cat may have done something with that. So you can see it's a lot of back and forth here. Script ran successfully. Okay, it's taking a little bit longer, which is totally fine here. Model FIMS which was not found. There's a lot of typos going on. Film ratings. So if we go into film_ratings, reference films, FIMS. Okay, here's the typo. Let's Docker compose down again. So also, if you're curious, if I'm Docker composing down -v, I'm actually killing the volumes every single time just to make sure that everything is working, even if we're starting straight from the beginning without any data persisting. So that's the only reason why I'm doing that. So now we Docker compose up again. This should work unless I've made even more typos. Okay, so we're doing that again. There we go. Okay, so now you can see that we've successfully run our models. So we've created a couple models here. The first one was the actors. The first one was the film actors. And the third one was the films. So these are all our references. So we've successfully taken that in, but now we've actually done the fourth one, which is the model for the film_ratings. So you can see that that's actually worked now. Now, if we were to go Docker exec -it, and then I think it was ELT destination _postgres -1. And then we do psql -u postgres. So then we go here, we do c destination _db, We connect there and then slash DT. So now you can see film underscore ratings, which is the new table that we've written in DBT is actually written now. If we select all from film underscore ratings and then with the semicolon, you can see that if I move this over, it's a little big, but you can see that our case has gone in here. It's kind of cut off just because of the way that my terminal looks, but you can see everything is in there. So we have our actors, we have our film ID, we have the release date, the price, but the most important part is the rating that we've created here. So the case statement worked successfully. So anything above a 4.5 was excellent. Anything below that between 4.0 and 4.4 was good, and you had no average one. So you could see that we've actually created this custom model successfully, along with the actor and the actor name. So you had Inception with Leonardo DiCaprio. It just looks a little weird because of the way that if I were to do this here, so let's do the same one. So now you can see it looks a little, well, it still looks a little weird, but anyways, you can see that it works. So that is creating a simple model in DBT. Now let's look at some other advanced options you can do inside of DBT to make your queries a little bit more dynamic is the best way to put it. Okay, so now that we've actually created the models, I told you that we're going to get into some advanced stuff with DBT. And that's why I mentioned the macros folder. So you can think of macros as sort of like a reusable components of DBT, where you may have some sort of queries that you want to reuse and is universal through pretty much all your models. So what if you could just create a macro where you didn't have to rewrite the same thing every single time? Well, you can absolutely do that with macros. Let's take the film underscore ratings file, for example. Let's say we wanted to generate this every single time. Now, that's probably not going to happen, but let's say we wanted to do it. And so let's just go ahead and actually take the whole file and cut it. Now, inside of the macros folder, what we're going to create is we're going to say film underscore ratings underscore macro dot SQL file. Everything's going to be a SQL file here. Now, what we're going to do is we're going to start the file with curly brackets. Both sides are going to have a parentheses, so double parentheses. And inside that, we're going to say macro generate underscore film underscore ratings. And then we're going to add a parentheses after. Now, the end of the macro is also going to have curly brackets, is also going to have double parentheses, but inside the percent signs, I think I've been saying parentheses, percent signs, you're going to say end macro in one word. Now, in between that is where your macro is going to go. So I'm going to go ahead and paste what we just took from film ratings into the macro. Now, film underscore ratings has nothing, but if we were to go inside of film ratings now, all we have to say is two curly brackets, and we're going to call the generate film underscore ratings macro. So you can see that this is the model that we're actually writing, and the macros never actually gets written. But if I were to go back into our terminal here, and let's close this, and let's say docker compose down -v, so let's kill the volumes here. We're going to say docker compose up, and it's going to run through everything all over again. So let's go ahead and let that go through really quickly. DBT is going to start running, and then you can see we still have 4 models being written. If we go back now over to the destination database /c destination underscore db and then /dt, the film underscore ratings table is still getting written. And if I do select all from film underscore ratings, you can see that we're still writing exactly what we wrote in film underscore ratings, but we've only been using the macro. So you can see that literally anything inside of the macro file in between this section here and here is going to be written exactly as shown. So if I were to say, let's create a macro for this case, which probably is more plausible than anything. So if I wanted to say generate ratings underscore macro dot SQL, and we wanted to do the same thing where we go percent sign this generate ratings, and then we're going to end macro, and then we paste this inside. All we have to do now is then just say generate ratings, call that, and then we should be able to do the same thing. If we do this, docker compose down v, docker compose up, let that run again. Yes, it takes a little bit of time to run it every single time, but this is just what it comes with. It would be much harder. Is undefined. Undefined. Generate underscore ratings. Fine. It's not generate underscore ratings. It's generate underscore ratings. Huh. Rating. Wondering if you can't call CTEs here. So now you can see kind of how macros could work. Is it allows you to have reusable queries throughout all of your whole DBT project, essentially, to just plug and play in and not have to rewrite the same thing every single time. So if you have reusable queries that you can use, go ahead and use macros, because it's very, very efficient in terms of, it implores the dry method of software engineering where, don't repeat yourself. You don't have to repeat yourself every single time if you have the same queries over and over and over again. So utilize macros when you can. Now let's move over into Jinjas, which is another feature of DBT. Okay, so this next section that I just mentioned with Jinjas are essentially what allow you to create conditionals or add control structures to your SQL queries. So for example, that we're going to use is, let's say we wanted to select a specific title, but using a Jinja, so we didn't have to actually put it within our actual SQL query. That's what it allows us to do. It could allow you to select, do we want to use the prod target instead of the dev prod target inside of our DBT project? Then we could do that as well. And we can change the way that queries are done, again, adding a control structure. So let's go ahead and inside of our example folder, we're going to create a file called specific_movie.sql. And inside of that is where we're going to start with our Jinja here. So again, starts with a curly bracket, $signs. And inside of that, we're going to say set. So when you see set, that is essentially what is starting our control structure here. And we're going to set film_title to equal, and for this example, we're going to say Dunkirk, because I know that's going to be a movie inside of the demo or the test database here. So Dunkirk is going to be a movie that we're going to look for, right? Now inside of that, we're going to say select. So this is the actual query itself, select all from, and we're going to reference the films table where, let's do capital, so sticking with the best practice here, where title equals, and then we can say in the single quotes, film_title. So that is obviously the variable that we've set up here, right? That's going to be our Jinja here. We're setting a control structure where we only want to select the title, where dynamically the value we've set here is Dunkirk. And obviously this can be anything we want it to be. But so let's go ahead and save that and then run our docker compose up here. Oops. And let everything go. And then we should, when DBT runs, we should have a fifth model that runs, which is going to be our specific movie. And so let's go ahead and let that run here. There's going to be the fifth. It's all passed. Very good. Let's run our destination database and /c into it. So destination_db/dt. And you can see specific movie is now a table inside of this database. And so if I say select all from specific_movie, you can see Dunkirk as well as all of its information, including the film ID, the release date, price, rating, and user rating, is going to be in there because we've used the Jinja in there. Now it allows you to pretty much do anything you want. If we wanted to go into the macro here and create conditionals where we have an excellent condition, a good condition, or an average condition, and we set those to be this number, we can absolutely do that. And it allows us to do that outside of the query. So that way we can know that up here, we can set it to a different movie. If we wanted to do Inception, we're only changing it Inception. Pretty sure that's how you spell it. If it's not, that's going to be very awkward. But so let's just do this, docker compose down v. Docker compose up. Let's run this again. And so when we run this, we should see that the specific movie has then changed over to Inception instead of Dunkirk, therefore showing that the Jinja works. And it allows for a little bit more readability, right? Because you can see that our film title, we've set it to a variable. We're not, manually searching for a movie here. And then we're going to do select all from a specific movie. And now you can see Inception is now there. So again, a very simple example of what a Jinja is and kind of how it works, but go ahead and play with it. I implore you to kind of integrate Jinjas with macros to really use the full power of macros and Jinjas together. And I think it could really 10x your SQL queries and your custom models from within dbt and really just excel that process of the whole data engineering / data analytics process altogether.